So guys, welcome back to my channel once again. So we continue from where we stopped in our last class in chemistry, and that is on electronic configuration. Don't forget that in my last video, I gave the concept of shells, the subshells, the orbitals, and the electrons. Alright? So today I'll be taking you guys on how to write down the configuration in the subshells format, which is the SPDF format. But a lot of you may be wondering that why can't I start from shells, which is the main energy? Now, you see, chemistry is very simple. But if you don't get, like I said before, if you don't get the right thing to do or right approach to answering questions in chemistry is a problem. Sometimes you need the second one to get the first one. So I believe this is the easiest way for you to understand the two at once. Don't worry, I got you covered. What you just need to do is just to like my videos, subscribe, stick to this channel, and I bet you will understand chemistry very well. Do you understand that? Let's start. Now, what is the first thing you need to do for you to write down the configuration in SPDF format? So get a kind of a table like this. Do a kind of a table like this S, then increase to SP, then increase to 3 SPD, then you have your SPDF. This is the first thing you should do. Now, the second thing is to attach the energy levels, of which I call the quantum numbers. Don't forget in my last video. 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. Then the next thing you need to do is to watch out for the numbers of what electrons. I also explained this in my last video, okay? Now, I said the numbers, so let me start from the orbitals. The numbers of orbitals, according to the quantum model, for S subshell is 1. For P subshell is 3. For D subshell is 5. And F is 7. So according to that rule, we now have what we call the Pauli's exclusion principle, which says that an orbital can have a maximum number of 2 electrons. So that is how we got this one. Since S subshell has 1 orbitals, 2 times 1 is what? 2. It's also part of what I explained in my last video. P subshell has how many orbitals? 3. 3 multiplied by 2 is what? 6. Why this is 5? 5 times 2 is what? 10. This is 7. 7 times 2 is what? 14. So which means that the total number of electrons that S subshells can have is 2, P 6, D 10, and F 14. So suppose we are now told to find the or write down the configuration of, let's take one of these elements. Let's take sodium, for instance. Sodium is having a atomic number of 11. I want to get the format of this or configuration of sodium in SPDF format. What do we need? Start from the top here and strike down this one, of which the arrowhead is facing down. That's why I say strike down. What do you strike? You strike 1s. The total number of electrons that S subshells can have is what? 2. You place the 2 here. So you'll be adding the powers until you get to 11. Once you get to 11, you stop. Go to the next one. What do you strike there? 2s. Still S subshells. Go to the other one. What do you strike here? 2p's. But the total number of electrons is what? 6. So let's check the power. Is it up to 11? This is 2 plus 2 is 4. 4 plus 6 is what? 10. It's not up to 11. Then you take this one. 3s. But you are not going to say 3s2. Like I told you, this is maximum number of electrons that you can have. So I cannot have 3x3. But I can have 3s1. Because I will need 1 here. The reason is because this is having a total number of 11. So if you add the power together here, it's 10. So I will just attach 1 here. Do you understand the concept? That is how to get the configuration in SPDF format. But now I would like to add something. What if you are told to find the period and the group to which this particular element belongs to? Stop cramming. I always tell my students, even my students I take physical classes, stop cramming. Cramming is bad. Take your time and understand the concept behind that thing, okay? Stop cramming. A lot of you now, if I ask you, what group and period does this guy belong to? You rush down to your periodic table and be checking for the group and period. You don't need that. From this, that's why I said that this particular topic connects, a lot of things. So for you to get the group and period, yeah, this is what you are going to do. Check out the highest energy level. The energy levels you have here are 1, 2, 2, 3. So the highest number there is 3. Then the group is determined by the subshells, the powers of the subshells. So this is the highest energy level. What subshell is it? S. What's the power there? 1. So it belongs to group 1. Just check the power of the subshells that have the highest energy level. Then you are good to go. Do you understand what I'm saying? Why to get the period is the highest energy level. That is what? 3. It's as simple as that. Do you understand that? So this is how you present or write down the configuration of elements in the subshells format. So I would like to give you an assignment. You can do well to tell us the configuration of magnesium with atomic number of 12. Tell the configuration and tell us the group and period to which this guy belongs to. So if you have your answer, you can drop in the comment section. So that will mark the end of our today's lesson. Don't forget to like my video, share this video, subscribe to my channel, follow me on TikTok and my Facebook page. I'll see you guys in the next one.